Apposite Technologies is proud to present Netropy 4.0. This is new firmware that installs on our existing Netropy products that has new features such as HTML5, the new topology view, a fully integrated RESTful API, and we've also added the ability to create more paths and endpoints. Let's jump in and take a look. To show you around, we have our model number at the top, the status of port 1 and port 2. We then have our engine listing here. This is a single engine unit, so it only has one engine. Right below that, in this box, we call this the topology view. And then on the left, we have the command margin. This allows you to turn on or off emulation. As a view, you can view your detailed statistics. You can manage some endpoint rules. You can add or create a path, or you can add or create an endpoint. I'm going to jump in really quick and create a very simple network. I'm going to create a network that emulates a line from New York City to Los Angeles. On the left over here, I will put in the bandwidth going from New York to LA. I'll say this is 100 megabits. And I'll say the return path is actually 50 megabits. So you can have a faster upload than a download speed or vice versa. For delay, I'm just doing a very simple constant delay of 80 milliseconds. So I'm going to set it to 40 milliseconds in one direction and 40 milliseconds in the opposite direction. Okay, this is all I'm going to do to create this simple path. So I'm going to go ahead and hit create, and I now see this path created on my topology view. I now have some clients and servers plugged into port 1 and some clients and servers plugged into port 2 that I want to test over the LA to New York network. So I'll do that by adding an endpoint. So we'll say New York City storage server is 10.0.0.10, and I'm going to assign that to port 1 onto the New York to LA path. So again, let's run over this. Port 1, I have an IP address of 10.0.0.10 as a server that's plugged in onto the port 1 side of thing, and I want it to take the New York City to LA path. So I'm going to create that. I now can see that my New York City storage server is rendered on my topology view. Let's create a destination for that. I'll create another endpoint. I'll call this LA backup server. I'll put him on port 2 because he's on the opposite side of the WAN emulator, and I'll give him the IP address of 10.0.0.11. And he's now on port 2, New York City to LA, with the IP address of 10.0.0.11. I'll create that. So now I've created a test scenario in my lab where a storage server can go over a link with 100 megabits in one direction, 50 megabits in the other direction, and 80 millisecond round trip time. And it can connect to the LA backup server. I'm going to go ahead and pause my recording here and add some more networks so I can show you around. Okay, as you see, I've added a few more networks. Let's go over some of the networks I added. I added a network called Wi-Fi with jitter between 40 and 120 millisecond delay. Looks like this is 15 megabits down, 8 megabits up. I created a SATCOM for a satellite communication with lots of jitter, anywhere between 900 milliseconds and 2 seconds, with 5 megabits down and 3 megabits up. And then there's a 5G video test network that I created called 5G video test with 60 milliseconds round trip, 80 megabits down, 40 megabits up. So let's go over how I configured some of these different endpoints. You saw me create the New York storage server with a single IP going to another single IP. Well, we could also parse this traffic in IP subnets. For example, in my Wi-Fi test, I have IoT devices phones, and you see it's an entire class C, 192.168.100.x will be assigned to this Wi-Fi path. And then all of these are class Cs. Here's 102, 103.x, and then here's just a single IP for the doorbell. So here we have IoT devices phones, IoT devices smart TVs, IoT devices game consoles, IoT device doorbell. So these three are a network, and this one's a single IP. And this is going to a single IP IoT controller, emulating as though it's in the cloud. So all of these networks and these two IP addresses are assigned to the Wi-Fi path. I also used an example using VLAN and VLAN ranges. So I've created a network called SATCOM, and maybe I have many ships out there that are using satellite communications that are on VLANs. Well, VLAN 100 through 199 will be assigned to the SATCOM path. The platforms, maybe there's oil platforms or other seismic platforms out there in the ocean being connected via satellite. They're on VLAN 200 to 299, and they're assigned here. And then, of course, we have remote locations as 300, 399. And then we have multiple backup where it's reporting its data to. We have the headquarters data center, which is VLAN 400 to 499. And then we have VLAN 500, 599 for the backup data center. We also have another way if you don't want a subnet. I've created another test. This is just a 5G test. It seems to be the buzzword nowadays. So this is a 5G network, and you can see that I'm going to have 10 iPhones on IP addresses 172.16.1.10 to 172.16.1.19. So that's 10 IP addresses. So maybe I would put 10 different iPhones on those IP addresses and do my video on demand testing over this network. And then I've given the droids 20 through 29 IP address. Right. So right now emulation is turned off. I have traffic running through it. I have it running through the New York City storage server to the LA backup server. So I should be getting 100 megabits when going from New York to LA. I currently have traffic running and emulation turned off. So if we look at bypass, I see that there is traffic running, 1 gig worth of traffic running through the pipe. As soon as I turn on emulation, since my source IP address is 10.0.0.10, it should take on the characteristics of this New York City to LA path. So let's go ahead and turn that on, and I should start seeing data flowing through here, which I do. And we can see here's 100 megabits, and we're getting a little bit less than 100 megabits because we have 80 milliseconds of delay as well. Okay, so let's say I'd like a little bit more information than just other than rate, frames, and bytes. I can come in here to detailed statistics, and I'll choose my graph that I want to watch, which is New York to LA. I'll crank this down to 5 minutes so we can see it. So one thing to keep in mind is from port A to port B is on this side of the graph, and port B from port B to port A, or from port 2 to port 1, is on this side of the graph. So that's orange. So from port 2 to port 1 is orange. From port 1 to port 2 is blue. So we can see I'm not sending much data from port 2 to port 1, and maybe I don't want to watch that, so I'll just turn it off. And we see now we're at 100 megabits sending from port A to port B. If I turn back on, I can still see it's 100 megabits on this side, but on the orange side it's only 2 megabits. If I want to see some other detailed statistics, I can expand my path view here and get other things besides rate, frames, bytes, drops, loss drops, reorders, duplicates, and corruptions. And to get back to the topology view, I can click here or I can click here. Okay, so everything you see me do here, I can actually do in the API as well. I'm not going to jump too far into the API, but I'm going to give you some quick examples. I have some pre-made scripts. I'm going to use Python to send API commands. This is RESTful API. First thing I'm going to do is I'm going to clear out everything. And what it's going to do is it's going to authenticate to the device and then send the cleanup command and turn off emulation, which is what we saw here done. So now maybe I want to retest. I'm going to recreate my traffic jam lab, which was the LA to New York. But I'm going to call it something different. I'm going to use my traffic jam build script, and it's going to build a new path, assign the endpoints, and turn on emulation. There's the path. Here's endpoint 1. There's endpoint 2, and then emulation is on. And now I'll see my traffic running through here. But yep. And then again, I'll clean it up. And it'll clean everything up and turn emulation off. There you go. Thanks for watching. If you have any further questions, feel free to contact sales@apposittech.com or support@apposittech.com, and we'll be happy to help you out.